Let us move to the new topic, and this time it is transistor configuration. Don't get mistaken with transistor biasing circuit and with transistor configuration. Transistor configuration is used when you are analyzing BJT in AC analysis. Okay? So, we have three types of transistor configuration. These are the common base, common emitter, and the common collector. Take note of the word common, it only means yung isang part mo ay inilalagay mo sa ground. So the first one is the common emitter. Sabi dito, it is frequently used in practical amplifier. At the same time, ang common emitter po ang pinaka-common na way ng pag-configure ng isang BJT. So take note of its input resistance and its output resistance or output impedance. So ideal po si common emitter kapag gusto mong mag-amplify ng voltage, ng current at ng power. Pero most common, ginagamit to para sa power amplification or power amplifiers. Take note, kaya po ito common emitter kasi kung titingnan mo ang emitter side, wala po tayong resistor at diretso ground siya. Hence, the name common emitter. So, kapag common emitter, ito po yung pinaka-default na configuration natin. Your input ay nasa base at ang iyo namang output ay nasa collector side. Again, grounded or common ang emitter at ang default na input ay base at ang default na output ay collector. Parati po iyon. Kapag walang binanggit ko anong configuration, common emitter po iyon. Okay? So, ang isang mahalagang parameter sa common emitter ay ang tinatawag nating common emitter forward current amplification factor. So, that is simply beta. Okay? So, beta nag-range siya from 20 to 600. Other references will tell you that it is from 10 to 150. So, beta again is just the ratio of IC to IB. Pag wala po ang beta, hanapin nyo lang po yung HFE. Beta kasi is R parameter and HFE is H parameter. Those types of parameters will be learned later. Next type of configuration is the common base configuration. Common base, common po yung ating base. As you can see, we have here an input at the emitter and our output default is in the collector. So, since hindi ka pwede maglagay ng input sa base, inilagay mo po yun sa iyong emitter. Okay? Ang feature po ng common base is that the current gain is equal to 1. If the current gain is equal to 1, we must assume that it offers the highest voltage gain among the three configuration. Ang isang parameter that we're concerned with common base is alpha. Alpha is the ratio of collector to emitter current. Alpha is always less than 1. It has the range of 0.9 to 0.9999. So, as you can see, this is a common base na sinold naman natin sa mga previous videos natin. So, your input voltage is at the emitter side and your output voltage is at the collector side. Again, pag common base, you have your input at the emitter and output at the collector. Default na output ang collector. Pero, paano na lang kung ang circuit naman natin ay common collector? So, common collector, another name is emitter follower. Kung ang common base is known for its current gain of 1, ito naman, common collector, it has the voltage gain of 1. If it has the least voltage gain, siya naman po yung may pinakamataas na current gain. Okay, common collector, saan ang default na input? Sa base. Okay, and since common ang collector mo, saan ka kukuha ngayon ng output? Sa emitter. So kung i-compare po ninyo si common base at si common collector at common emitter, laging ang pampalit natin sa paglalagyan ng input or output ay ang emitter side. Okay? Ang parameter na concerned naman tayo kapag common collector is the gamma. Gamma is the ratio of IE over IB. At between gamma, beta, and alpha, pinakamalaki po si gamma. So, this circuit, I have already solved this from the previous videos. You see, the collector side is grounded or common. Thus, this is a common collector. You have your input voltage here at the base and kinuha mo yung output voltage mo across your emitter region or emitter layer. Okay? So, recap lang po tayo. We have three configurations: the common emitter, the common base, and the common collector. The most common is the common emitter, which is used for power amplification, but is also good for voltage and current amplification. Current base has a current gain of 1 and is very ideal for voltage amplification. It has the highest voltage gain. While common collector, also known as the emitter follower, is known for having a voltage gain of 1 and is most ideal for current amplification. If common base is ideal for voltage amplification because it is the highest voltage gain kasi common base voltage. Okay? Ito naman, ideal para sa current amplification. Common collector, current. C, current, voltage, V. Artihan mo na lang, okay? So, common emitter, default, ang input laging sa base, ang output sa collector. Paano po pag common base? Again, default, common base, output mo collector. Kaya lang, ang ipampapalit mong input dahil common ang base ay emitter. Common collector naman, common po ang ating collector, ang input natin nasa base pa din, kaya lang hindi mo pwedeng kuhain ang output sa collector at dahil hindi pwede sa collector, saan mo yun kukuhain? Sa emitter side. Okay, so this is the quick summary of transistor configuration. Don't forget to subscribe! So, let me explain lang this table. So, palatandaan, common collector, it has the lowest voltage gain, it is 1. While common base, it has the lowest current gain, which is 1. Laging moderate lang po si common emitter, except sa power gain, which is highest naman po siya. Okay? Paano ba nakuha ang power gain? Ang power gain po kasi ay voltage gain times current gain. So, tingnan nyo to. High times low, babagsak lang tayo sa katamtaman or kasarapan, that is moderate. While common collector, lowest times highest, again, parang extreme to extreme, extreme tsaka lowest, babagsak ka lang sa katamtaman ulit, which is moderate. Pero pagdating kay common emitter, you have voltage gain and current gain, which is at the same time moderate. So pag pinag-multiply mo yan, parehas tataas, kaya ang power gain mo ay highest. Okay? With regards to phase inversion naman guys, common emitter is the only one which has phase inversion. Sa easy analysis natin may encounter yung tinatawag na phase inversion. So common base is used for RF amplification. Common emitter is universal, either voltage, current, or power, but most ideal for power amplification, while common collector is mostly used for isolation. Okay? So, may kabisado of this table. So, let's move with linear amplifier. So, Kung sa DC analysis guys, ini-ignore po natin ang ating mga capacitor, sa AC analysis, magagamit na po natin siya. Okay, yung dalawang capacitor po na ito, yan yung tinatawag nating coupling capacitor. Ngayon, nabanggit natin kanina na common emitter lang po ang merong phase inversion. Ano po ba ang ibig sabihin ng phase inversion? Sabihin natin na ito po yung ating input voltage. Okay? Pagdating mo dito sa output side, kung i-observe mo to, na-amplify siya kaya lang bumaligtad na po. See? Okay? So, yun yung tinatawag nating phase inversion. Okay? We have two types of amplifiers kasi BJT is most commonly used for amplification. You have the small signal amplifiers, which is used to amplify small signals, and you have the large signal amplifiers or power amplifiers, and is used for large AC signals. So, in any system, kapag magko-convert tayo ng BJT natin to AC model, you have to take into consideration of having an input resistance and output resistance, at the same time, input voltage and output voltage. So these are the parameters that we are concerned. The ZI, the ZO, the AV, and AI. ZI, input impedance as seen here. So impedance, resistance lang. Output impedance as ZO, voltage gain, and current gain. Although current gain hindi naman siya madalas hinahanap, ang madalas pong hinahanap ay voltage gain. So, in converting a certain diode into its AC equivalent circuit, we have to use two parameters, either of the two. So, most common is the R parameter. Kapag Floyd ang ginamit mo, H parameter doon. Kapag Boylestad, R parameters po. Ang ginagamit ko, R parameter, kasi mas common po siya. So, this is an example of R parameter. And this is an example of H parameter. So, what's the difference between the two? Observe ha, yung isa may diode. Pag kasi R parameter, it employs diode and controlled current source. Balik ko lang po dito. Alin po ba yung controlled current source? Ito po yun. Controlled po ito kasi IC po ito. Si IC ay nakokontrol ng alpha IE. From this fact also, we can see that BJT is really a current-controlled device. Okay? So, disadvantage lang po ng R parameter sabi dito is that sensitivity to DC level. So, these are the R parameters. You have the alpha, the beta, the R prime E, the R prime B, and the R prime C. Pinakaginagamit lang po si beta at si R prime E. So, si R prime E, yung AC emitter resistance, is just 26 millivolts all over IE. Si IE po na ito ay makukuha natin kapag nag-solve tayo ng DC analysis. Kaya sinasabi na si R parameter ay masyadong sensitive sa DC levels. It is due to the fact na ito ay manggagaling sa DC analysis po natin. 26 millivolts, this is the thermal voltage lang po. Sa mga lumang version ng libro, this is equal to 25 millivolts. Okay? Ito naman po si H parameters. Doesn't employ a diode. So, we have here HI, HR, HF, and HO. So, less po na ginagamit to kumpara kay R parameter. Mas common pong gamitin si R parameter. And paka-take down lang po ng notes nyo. Kapag kayo ay nag-analyze ng BJT into saturation, ang ginagamit po natin ay yung Eber-Mols model. Eber, EBR dash MOLLS space model. Okay? So, let us just compare the R parameter and H parameters. So, So this one, H parameter, convertible naman po yan into R parameter. Pero do not expect that I'll teach you how to convert H to R because that is unnecessary. Okay, lalo na kung magbo-boards ka. Madaming tanong about AC pero nilulok spam na lang naman po yun ng iba. Pero papakita ko sa inyo mamaya yung mga problem sa Injabix isosolve po natin. So these are the steps on how are you going to convert a certain DC circuit into its AC equivalent circuit. So first one is the common emitter configuration. Your diode could be represented by this model. You have an input resistance beta RE, and you have here in the output side the controlled current source beta IB, or simply that is your IC, and you have an equivalent output resistance. Remember, ito po yung equivalent circuit ng diode lang po natin. Diode lang po. Hindi pa po kasama ang ating buong circuit. So, moving on, let us convert this circuit into its equivalent AC model. So hello guys, let us convert our DC equivalent circuit into its AC equivalent model circuit. Okay? So sabi, first step, ipa-flash ko sa screen. First step is that yung mga sources natin, isi-zero natin at papalitan natin ng short circuit equivalent. Or in other words, yung ating source ay i-connect natin sa ground. Second step, ang mga capacitors natin, coupling capacitors and bypass capacitor, ito po yung bypass, itong dalawa ay coupling, ay papalitan natin ng short circuit equivalent. Pag sinabing short circuit equivalent, edi papalitan lang natin ng wire. Okay? So, siguro di nyo pa na-figure out. Ito kasi, pwede kong paghiwalayin. Ground lang naman to, di ba? Yan. Ito, tsaka ito at ito, connected lang po sila. And then, i-drawing ko ito into a more logical form. Nandito si RC. I'm sorry, this is RB. And then, ito yung ating VO. And then, ito si RB. At ito yung input voltage natin. So, ito na po yung converted natin na circuit. Kaya lang, si BJT, papalitan mo ng kanyang AC equivalent circuit. Ang AC equivalent circuit ng isang BJT, kapag common emitter, ay ito po. Meron kang dependent current source, beta IB. Meron akong output resistor, RO. At meron akong input resistance na beta R prime E. Si R prime E po, yan yung tinatawag nating AC emitter resistance. Si R prime E po ay equal lang sa 26 millivolts R prime E over I E. Okay? Redraw ko lang to ng mas malaki. So, ito na po ang equivalence ng ating diode sa AC. Now, paano ko pagkakabitin ito tsaka ito? Okay, remember, itong buong ito lang po yung diode natin. Okay? So, si RB, ilalagay ko dito. Andito naman ang ating input voltage. Ito si RB. Next, sa output side tayo. Si collector, itatap ko lang po dito. At ito na po yung ating output voltage. So, ito, papuntahin ko dito. At ito na po yung gagamitin ko sa pag-compute ng ZI, ZO, AV, at AI. Okay guys. Copy. So, let me derive some of the formulas para ma-minimize yung sasauluhin nyo. First is the ZI or input impedance. Okay? Pag input impedance, yun yung resistance, total resistance sa input side natin. So, tingin sa input side, makikita nyo that your RB and beta R prime E is just in parallel. That is why your input impedance is equal to RB parallel with beta R prime E. That is the exact analysis. Now, paano naman ang ating approximate analysis? Approximate analysis is when RB is greater than or equal to 10 beta R prime E. Kapag ganyan, ZI is approximately equal to beta R prime E. Kapag po ikaw ay nag-AC analysis, pinaka-practical gawin ang approximate analysis kasi pinakamadali po yung formulas doon. Okay? Next thing, kapag ZO naman tayo. Kapag ZO tayo guys, again, your output resistance here and RC is in parallel. That is why ZO is RO in parallel with RC. This is only true if RO is equal to infinity ohms. Bakit po? Check natin. Kung ang RO ay infinity ohms, di ba? Paano nagpa-parallel? Inverse. So, 1 over infinity plus 1 over RC inverse. Tama po ba? Okay? So, 1 over infinity is 0. Ang matitira mo na lang is 1 over RC. Kaya, yung isa nating approximation is that ZO is approximately equal to RC na lang po. So, yan lang guys. Ito mangyayari when RO is greater than or equal to 10 RC or simply when RO is equal to infinity. Sinasabi naman sa problem kung ang ipagagamit sa'yo ay approximate analysis or exact analysis. Kapag hindi sinabi, may ganun ding problems, well, bahala ka na po kung ano yung gagamitin mo. Minsan kasi sa mga references natin, sa book natin, basta na lang gumagamit din kahit hindi naman sinabi kung ano yung dapat mong gamitin. Okay? So, ito lang yung way ng pag-derive ng ZI at ZO. So, I guess ready na kayo para mag-solve ng isang circuit. Okay? So, copy your notes. Let us solve this first problem. Okay, so ito yung problem natin. Hahanapin natin si R prime E, si ZI, at si ZO, and si AV kapag ang ating RO ay infinity ohms. So, para makapag-solve ka ng AC, kailangan mo munang mag-DC analysis. Kasi kailangan mong makuha ang value ni emitter current IE. So, KVL tayo dito. Okay? So 12 minus 470 kilo ohms times, sino nadaan? Si IB. Tapos ano nga meron dito? Voltage drop na 0.7. So minus 0.7 bagsak sa ground equals sa 0. Now, kuhain ko muna si IB. Store lang po yung values. Ang value ni IB ay 24.04 microamperes. Okay? Kung gusto kong kuhain si IE from our DC analysis, that is beta plus 1 IB, or in this case, beta is 100. So this is 101 times 24.04 microamperes. IE is equal to 2.43 milliamperes. Okay? Pag meron na akong IE, makukuha ko na si R prime E. Si R prime E po ay equal sa 26 millivolts over IE. So, 26 millivolts divided by 2.43 milliamperes. R prime E is 10.71 ohms. So, ayan na yung ating isa sa pinapakuha. Okay? And then, pwede ko nang kuhain si ZI, si ZO, si AB, and si yan tatlong yan. Okay? Again, ZI is equal to RB parallel with beta R prime E. So, RB is 470 kilo ohms. I-parallel ko yan sa 100 times 10.71 ohms. So, ZI is equal to 1.07 kilo ohms. Okay? How about ZO? ZO is equals to RC. Why? Because RO is infinity ohms. So, approximations po. Dito naman, pwedeng ang ZI mo, alternatively, is approximately equal to beta R prime E. Okay? Kasi kung gagawin mo yon 100 times 10.71, parang equal na lang din po dito. Konti lang naman yung discrepancy pag nag-exact tsaka approximate analysis ka. Kaya huwag kang mag-alala. Piliin mo lang sa choices yung pinaka malapit. So, ZO is equal to 3 kilo ohms. Next, how about AV? AV is equal to negative RC over R prime E. So this is equal to negative 3 kilo ohms divided by 10.71. Your AV is equal to negative 280.19. Okay? Remember, may negative po yung voltage gain natin dahil we are using Common Emitter Configuration kung saan meron po tayong tinatawag na phase inversion. Okay? At si Common Emitter lang po ang merong phase inversion among the three configuration, the Common Emitter, the Common Collector, and the Common Base. So, copy your notes. So, follow-up question naman guys, paano naman daw yung AV at ZO kapag meron na tayong RO which is 50 kilo ohms? So, mag-exact analysis tayo at i-compare natin yung values natin with the previous computations. So, ZO, exact analysis is RO parallel kay RC. So, that is 50 kilo ohms parallel with RC which is 3 kilo ohms. So, this is 2.83 kilo ohms. Hindi nalalayo sa na-solve natin kanina, which is 3 kilo ohms, di ba? And then, your EV is exact analysis, that is negative RC parallel with RO over R prime E. Okay? Di ba ito ay ito lang po? So, that is negative 2.83 kilo ohms in parallel with 10.71 ohms. Your AV is negative 264.33. So, compare kanina sa 280, medyo malayo ng konti, pero still, medyo magkalapit pa din pag i-round off mo to the nearest hundreds. Okay. So, yan po, nakita nyo yung difference. Again, may negative kasi common emitter tayo, meron tayong tinatawag na phase inversion. So, copy your notes. Okay? Ang atin namang aaralin ngayon ay isang voltage divider bias na bypassed. Tandaan na, bypassed. Kasi meron tayong unbypassed. Ang effect po kasi ng pag-bypass natin is that mas napapalaki natin yung gain at mas nakakapagpataas po yun ng stability sa ating circuit. Okay? Ano ang tawag sa dalawang capacitor? Coupling capacitor. Ito po, yung capacitor across the RE or emitter resistance is yung tinatawag nating bypass capacitor. Okay? Okay, what's the first step nga in making the AC equivalent circuit? You have to zero the voltage and set it to the ground. So, isi-zero ko lang yan and isi-set ko na lang to sa ground. And then, yung mga capacitor natin ay papalitan natin ng short circuit equivalent or simply gagawin lang po nating wire. Okay. Anong effect kapag i-short mo ito? Or kapag i-short mo yung bypass capacitor mo dito? Diba shorted na si RE? Magiging wire na lang po yan. Pag pinag-parallel mo yung wire, wire pa din po. Walang ibang mangyayari doon. Okay? And then, i-redraw ko siya. Okay? Si diode, papalitan ko ng AC equivalent circuit. Ano ang meron ulit doon? Beta R prime E. Tapos meron kang isang current source. At meron kang RO. So, ito po na yung diode natin. Tandaan, diode. Ito na po yung transistor natin. Transistor pa lang po yan. Then, ikabit ko ito. Diba, pwede ko itong hatakin pababa. Pag ginawa ko yun, meron akong R1 tsaka R2 dito. And ito si VI ko. Sa kabilang side naman, nandun naman po ang ating RC. And ito yung VO ko. And then, tingnan na lang natin at makukuha na natin or magkakaroon na tayo ng idea sa pagkuha ng input resistance and output resistance or input impedance or output impedance. Again, impedance is just like resistance. Ang impedance nga lang po, kasama na dyan yung reactance. Well, sa circuits to na naman po yun. Okay? So, kapag kukuhaan ko si Zi, parallel ko muna to, that is R prime, and then that combination parallel with beta R prime E. R prime, parang RTH lang natin sa voltage divider. R1 parallel with R2. Okay? And then yung ZO natin, ZO, kung titingnan mo, parallel lang po si RO tsaka si RC. And again, meron kang mga approximations na pwede mong makuha. And if-flash ko na lang po yun sa screen. So, pakitandaan na lang ng mga formulas natin, pakikibasado, and huwag nyo na lang kalimutan tong drawing na to. Kasi from that, makikita nyo agad kapag tinignan ninyo kung alin ang ipaparallel mo sa input at sa output. Okay? So, copy. So I have here a sample circuit and we will find R prime E, Zi, ZO, and AV. Okay, I decided to use approximate analysis throughout my solution. So pag dinisi analysis ko to, mag-approximate analysis na lang po ulit ako. So paano nga si approximate analysis? Kailangan mo munang isatisfy if beta RE is greater than or equal to 10 R2. So beta natin is 90. RE is 1.5 kilo ohms. Is it greater than or equal to 10 R2? So 10, ang R2 nga natin ay yung baba or R lower natin, which is 8.2 kilo ohms. So 90 times 1.5, that's 135K. 10 times 8.2, that's 82K. So, since it is greater, pwede po ako mag-approximate analysis. In approximate analysis, kuhain ko muna si VB. That is 22 times 8.2 all over 8.2 plus 56. So that is 2.81. Pag nakuha ko si VB, pwede kong kuhain si VE. That is VB minus VBE. So that is 2.81 volts minus 0.7. That is 2.11 volts. Pag meron akong VE, makukuha ko na si IE. Equal lang yan sa VE over RE. So that's 2.11 over 1.5 kilo ohms. Si IE ay 1.41 milliamperes. Pag meron akong IE, makukuha ko na si R prime E. Dahil si R prime E po ay equal lamang sa 26 millivolts divided by IE. So, 26 millivolts divided by 1.41 milliamperes. R prime E is equal to 18.48 ohms. Okay? So, meron akong R prime E. Paano ko kukuhain si Zi? Si Zi is R prime parallel with beta R prime E. So, medyo sikip. So, again, R prime is equal lang sa R upper parallel kay R lower or R1 parallel kay R2. Kapag ginawa ko yun, 56 kilo ohm parallel with 8.2 kilo ohms. So that is 7.15 kilo ohms. Zi is 7.15 kilo ohms parallel with 100 times 18.48. So Zi is 1.47 kilo ohms. Zo is RC, so that is equal to 6.8 kilo ohms. Kita pa ba? Pasensya na ha, medyo siksikan. And then si AV, that's negative RC over R prime E. So that's negative 6.8 kilo ohms all over 18.48. That is equal to negative 367.89. So, meron akong AV, meron akong ZI, meron akong ZO. Actually, mali yung nagawa ko sa ZI kasi ginamit ko is exact analysis. Pero hindi naman malayo yung sagot. Again, nasa sayo kung approximate or exact yung gagamitin mo. Pero kapag i-specify sa problem kung ano, gamitin mo kung ano yung sinabi doon. Pero pag wala, nasa sayo na po yun. So, copy your notes. So this formula, guys, is for emitter stabilized and voltage divider bias, wherein the RE is unbypassed. So let us solve this circuit. First condition is for unbypassed and the second condition is for bypassing the 0.56 kilo ohm resistor. So keep watching. Ang meron naman ako ngayon ay isang common emitter na emitter stabilized bias. Okay? Malinaw na sinabi sa problem na wala tayong bypass capacitor. Okay? And yung na-flash kanina is yung mga gagamitin nating formulas for this specific problem. So we need to find the R prime E or the AC emitter resistance, the ZI, the ZO, and the AV na unbypass si RE. Ano nga yung first step? Kailangan ko munang kuhain si IE. Okay? Andito po si IE. Andito si IB. Andito naman si IC. So, magki-KVL lang ako mula dito, pababa po dito. Okay? So, alam ko agad na si IE ay papaltan ko ng beta plus 1 IB. So, in this case, beta is 120. So, I is 121 IB. So, KVL na ako mula dito. 20 minus for 70 kilo ohms. Trace lang yung wire. Na ang nadaanan si IB. Minus, may voltage drop dito na 0.7. Minus 0.56 kilo ohms. Na ang nadaan ay si IE, pero si IE nga ay equal sa 121 IB. Bagsak sa ground equal sa 0. IB is equal to 35.89 microamperes. Kung gusto kong kuhain si IE, 121 IB lang po yan. Equals po yan sa 4.34 milliamperes. Pag meron akong IE, makukuha ko na si R prime E. Dahil si R prime E ay equals to 26 millivolts divided by IE or 5.99 ohms. So, meron na akong R prime E. Okay? Store ko po yung value para walang tapon. So, to get ZI, that is equal to ZB parallel with RB. Now, to get ZB, that is equal to beta R prime E plus RE. May approximation po tayo na equal lang to sa beta times the DC emitter resistance, RE. Bakit po? Kasi yung value ni R prime E compare kay RE ay napakaliit. In this case, meron tayong 0.56 kilo ohms or 560 ohms. Compare mo with 5.99, diba actually mas malaki ng almost 10 times. Kaya madalas nine-neglect na ang value ni R prime E at ito na lang yung nagiging formula natin. Anyways, I stick with this one. So this is 121 times 5.99 plus RE which is 560 ohms or simply 0.56 kilo ohms. And this is equal to 67.92 kilo ohms. Okay? And then to get ZI, that is 67.92 kilo ohms in parallel with RB which is 470 kilo ohms. And this is approximately equal to 59.34 kilo ohms. So meron na tayong ZI. Next thing is to find the value of ZO. Now, ZO is simply equal to RC. Ito lang po. So, that is equal to 2.2 kilo ohms. Okay. To get the value of AV naman, that is equal to negative RC all over R prime E plus RE. Again, may approximation po tayo that this is simply equal to negative RC over RE due to the fact that the value of R prime E is very small compared to value of RE. Whatever you use, your tama naman po. Okay? So, that is negative 2.2 kilo ohms all over 5.99 plus 560, and your voltage gain is equal to negative 3.89. Okay? Ano yung gusto kong take away nyo dito? Notice that the voltage gain, hindi pa siya umabot ng times 10, di ba? Compare sa nakuha natin at mga na-compute natin kanina, which is nasa values ng hundreds. Remember na ang ating circuit dito ay unbypassed. Unbypassed, ibig sabihin, yung capacitor dito, wala po. Hindi tayo naglagay. So, as a conclusion, nakita nyo naman na kapag nag-install tayo ng isang bypass capacitor, mapapataas mo yung gain. Therefore, yung stability mo mas nagiging okay din. And then, kapag wala kang niligay or in-install na bypass capacitor, ang tendency nun is that bababa po yung gain mo. Less stable yung circuit natin. Kaya, yan o, nakita nyo po. Okay? Mamaya, sa sunod nating solution, kukumpute naman natin itong circuit pa din na ito kapag naman meron na tayong in-install na bypass capacitor. At i-compare nyo yung voltage gain natin na makukuha kapag unbypassed and bypassed. Okay? So, copy your notes. Okay? Same circuit but different scenario. Different scenario kasi this time, mag-i-install na tayo ng isang bypass capacitor. Okay? Wala pong magbabago doon sa R prime E natin kasi galing naman to sa DC analysis natin eh. Okay? Again, ang effect po kasi ng bypass capacitor, ibinabypass nyo tong 0.56 kilo ohms. Pag sinabi natin ibinabypass, hindi na pinapadaanan. Sa kanya na dumadaan. So, isino-short niya na ito. Okay? So, kung shorted po ito, so, kung shorted lang po ito, yan na. Okay, shorted na po. So, di ba ZI, yun pa din naman po. That is ZB parallel with RB. ZB, di ba yan ay beta R prime E plus RE. Pero guys, dahil binypass natin si RE, wala na tayong value ng RE ngayon, 0 na. Kaya yung ZB natin kapag bypass ay beta R prime E na lang po. So that is 100 times 5.99. So that is 598.71 ohms. To compute for the value of ZI, that is ZB, which is 598.71, parallel with RB, which is 470 kilo ohms. So, 597.95 ohms. Kung nakita nyo, hindi malayo ang value ni ZI kay ZB natin. Okay? Si ZO naman, still, RC pa din po yun, which is 2.2 kilo ohms. And then, AV. Si AV, di ba kanina, negative RC over R prime E plus RC. Plus RE. Kaya nga lang, tulad ng ginawa natin, isiniro natin dito kasi shorted na siya due to the bypass capacitor. So, dito, isisiro ko din, makikita nyo na ang AV kapag bypass na is negative RC over R prime E. So, your RC is negative 2.2 kilo ohms all over 5.99. And you'll see that the voltage gain is negative 367.45. It has dramatically increased when you add a bypass capacitor here. So it is very clear that adding a bypass capacitor increases the gain. While not installing a bypass capacitor, the tendency is that the gain will be lesser or lower, as seen in our computation. Okay? Tandaan nyo, i-take down nyo yun kasi napapatanong po yun, yung effect ng paglalagay ng bypass capacitor. Okay? So, it provides an AC ground kasi. Okay guys? So, take down these computations.